This is the coupling project, so make sure you open up your PDF of the projects. You can get that from the publisher site, or you can get it directly here, lesson projects download, and it's also on your lecture page. So once you go to the CAD resources site, you'll also see that we have the standard coupling parts here. And I'll shut this right now. So basically you want to open up the section on the coupling assembly and read through it before you start, because it will give you all the information you need to know about all the different components. Now, of course, you've already modeled the coupling shaft and the taper coupling and the straight coupling. So after you've done that, then you're going to be doing the assembly, but you want to load the washer and the jam nut and the hex nut and the cotter pin and the socket head cap screw. These are all standard parts from Pro Library. And if you go down a few pages here, you'll have the commands. It says File, Open, Pro Library. It might say Creo Library, depending on what you have loaded on your system. But all of these are in the standard parts. Again, if you want, you can model them, or again, you can take them directly from the book website. Now, I'll show you a few pictures of the exploded view and other things, but in general, and then the drawings at the end. We'll cover that separately. So I think I'll just reduce that. And I opened up the assembly already, and I turned off the datum features just so we could take a look at it. And we can take a look at the exploded view also, the default exploded view. And you'll see the ones that are needed. You got a dowel, socket head cap screw, a washer, jam nut, and a cotter pin, and you're going to bring in a key also that's been provided. You can also model the key, of course. And the three major components you've already modeled. All right, I'll close that. So let's start a new assembly. I'll use the default template, and we'll turn everything on. And I think we'll do it this way here, because in the View tab, we've got everything available, including the datum tags. So we'll turn everything on, and we'll, of course, change our tree filters so that we can see the features and annotations and suppressed objects in the tree. Now, this is a metric assembly. All your parts were supposed to have been created using millimeters. If they were not, you should go and open them up and check, make sure that's what you have, because this time we're actually going to remember to do it in the very beginning. So we're going to prepare and go into model properties, click on units, and we're going to change the default, in this case here, to millimeters. And because nothing is on the screen, there's no components, no features, really doesn't make any difference which one of these model units changes that you use. Normally I'll say always use the one on the bottom, just out of habit, because it's normally the one you're going to want to have. And we'll say play, okay, and close. And then we'll bring in our first component. And this one, of course, will be our shaft. And we'll put that right mouse button at the default, in other words, coordinate system to coordinate system. And if we want, we can actually go over and change our options so that the model display is isometric. That really doesn't help, doesn't look that good. So I think I'll rotate the model around before we start putting other components on here. All right, so we're going to assemble our next one, and maybe in this case I do want to shut off my datum features. Let's see, I don't think I'm going to need them. And I'm going to bring in the first coupling, which is the taper coupling, and I'm going to select on the tapered surface on both. Now, in order for this to work, you have to have the exact same degrees on both of them. Some people accidentally model their components, and there's a slight difference or a major difference in the degree angle here for the two tapers. So they have to be identical. And I'll slide this one here. And coincident, we're going to use centered, and it will jam itself in there, kind of like a mate. All right, so now the next one we're going to need to position it one more direction. You can see in here that we do not need the third direction, so we're going to allow assumptions. So we need a new constraint. And I'm going to turn on my hidden lines. See if I can get this. It's a little confusing looking here. Now, at any time you can actually change this, get a little bit better visual. I can go back to my first constraint and disable it. And what that allows me to do is move this out, and then I'll go into the next constraint, of course, and this is the one I want to use. So for instance, I want to pick this surface here, and in my model here, you can see it's turned. The question is, am I going to get the right one? I want this one here. Let's see. And let's go back over to my other one and turn it on. And it says it's fully constrained. So if you get the wrong direction on this, it'll flip it around. And let's see, it looks like that's what we got. So let's go back into our no hidden. Now let's go into hidden and see if we can see what happened here. So you can see it's way over here with the cut. So it says centered. On this one you can see they're flipped here. Now let's try parallel. Let's go with coincident and flip. There we go. So now they're planar, coplanar, or coincident in this case. They call it coincident. And you have them lined up. All right, now let's put in the key. Now, in order to see the key better, we can just click on the component here and hide it, and then bring in our next component. And we'll move it over close to where we want to do our work. And let's put it on the flat on the bottom here. Pick that. And then how about the surface here? Right mouse button to get the filter through this. You can turn the model if you wish. And that one, of course, is going to be coincident. Also, popped way over there for some reason. Not sure why. The distance, this one was supposed to be coincident also. And let's flip this. It's funny that it's way out here. A little difficult to see, obviously, because it's inside there. Let's see if there's a position we can move it to. You can see here, so it is on the wrong side. I'm going to flip it again. And there it is. Now I still have to position it this way. So what I'm going to do is I'm going to use these edges here. First of all, the tangent edge. So new constraint, put my cursor here, hit my right mouse button, and I can't pick that up very easy. So let's go over here to this one first, and let's pick the edge, and then go and try to select the tangency edge. Right mouse button until you get it, and it's going to be coincident. Check. Now we could go over to our analysis at this point and see if there's any interference. And there is not any interference, so it doesn't fit. So if yours is a little too long, you can of course activate the key and make it a little bit shorter. Whatever you need to do. Mine is the correct size. Yours may not be, by the way. So if I unhide my taper coupling, Next thing I want to do is I want to put on a washer. If we look at our project here, we have a washer inside and a jam nut. So model tab, assemble, and we're going to go to the washer. It's way out here, so I'll move it to this side. And now I'll start with the flat first this time. I'm just going to pick there, and I'm going to pick on one of these two portions here. I'm not sure which one is lower, truthfully. I think I'll grab this one right here. We'll see if it's the right one. And that one's going to be coincident also. And the second one is going to be the shaft diameter and the inside of the washer. And we can see what happens here. We might try flipping this. There we go. And check. Now, right off we can see there's a giant gap in here. So something's wrong with the size of our washer. And we can click on analysis and diameter, and let's measure the diameter of the threaded end here, which is 30. And then the diameter of here, and it's 33. So let's open up this washer. And first of all, let's put a different color on here. And second of all, let's just double click on it. We'll see it's 33, and we want to make this 30. Regenerate it, close, go back over, and we can see it's now up against there. Okay, next thing we want to do is bring our jam nut in. And the book actually tells you if you don't have enough distance here to engage with the jam nut, then open up your, I shouldn't say the book, but the problem set, open up the part itself and make this longer at the end so that you have a little bit more to engage. Open this up and we can see this is 28. Let's make that 32. And regenerate it. And close it and then go back to the model and let's regenerate this one. You can see it sticks out a tiny bit more. All right, so let's put on our next component, which is our jam nut. Get the hex nut. Oh, hit the wrong one. Not the slot nut, it's the hex nut. Move the component. And let's use the bearing surface here and the bearing surface there. And flip it. And then add the inner surface here to the threaded area. And that one should be coincident. I'm not sure it's so wide so far in there. Oh, because we have distance. This is supposed to be coincident. And there it is. So you have your jam nut. Next component we're going to put on is the second coupling, the straight coupling. And I think what I'll do is I'll line up this dowel to this dowel. And then also add the shaft here, the hole. And I'm just going to line it up with a curved surface on the other side. Looks pretty good. Going to need a third one, and it's going to be the two bearing surfaces. Make sure there's a hole. You can see through the holes. Just make sure they're aligned correctly. Check. All right, next thing is we'll put in our socket head cap screws. But before we do that, on this taper coupling, we want to see what the first hole was. So it's this one over here. It's the first hole that was put in and then it was patterned. So we wanted to know that. So that's where we're going to insert our first no, I can't find it there. Socket head cap screw. And you can rotate this around. You really don't have to get this fancy. Basically, as soon as you hit your curved surface here, it's going to know where to go. Now, if you want, you can actually do the bearing surface first. But I think I'll do the curved. I usually like the curved surface first. You can use center line or axis to axis also. And now the bearing surface as the second set. Right mouse button, get the bottom, or just rotate it around. And that one is going to be coincident also. And what I think I'll do is I'm going to turn on my datum planes, and I'm going to add a third one. Third set. So right mouse button, new constraint, and I'm going to put the datum plane down the socket head cap screw. If yours doesn't have a datum planes, you're going to have to put them on your standard part. And then I'm going to click on something that's going in the other direction. Could use the assembly datum. Normal angle offset. There we go. Now I can change the angle. No, that's not what I want. It's funny that it gave me that one. So let's get rid of that. Add a new one. Click that, and let's click this one. No, it's still giving me that. Oh, I know what. I'm selecting the wrong one. I need the one that goes down the middle here. There we go. Now you can see you can change the angle. I'm going to move the angle like so. So it's not facing the hub. I can get to that angle at any time now and make changes. Now, next thing is we're going to put in our hex nut. Oh, sorry, hit the wrong one. It's the slotted nut that I need. And I'm going to pick the curved surface on the inside and then the shaft of the component. Bring it out. I'm going to select the bearing surface here. And the bearing surface at the bottom of the nut. If you have a long part, turn off your spin center, and then wherever you click, that's where it'll rotate about. And this one should be coincident. And I think I'll add one more if I can. I don't know if this one will work. curved here and curved here. It's going to say it's invalid, I think. Oriented. How about coincident? No, it doesn't like that. Parallel. Oh, parallel worked. That's kind of odd. But it did work. Of course, anybody who knows anything about mechanical devices knows that you don't put a cotter pin and a slotted nut here on a moving machinery, but hey, we're just practicing. And let's get a different color on here. I always struggle with my colors. Gray is okay, I guess. Sometimes when you have so many choices, you don't know what to do. How about metals here? How about chrome? What do we got for chrome? All right, a little bit of differentiation. All right, now I'm going to put the cotter pin in. And I'm going to move it over here until I get a position I like. Like so. And I can actually add a constraint here. How about if I use the flat end of the cotter pin with the datum plane going down the middle of the socket head cap screw. And it's got distance in there, and I'll just leave whatever distance it is. I can change it later. And if I put in a new constraint, how about the one that goes down the middle of the cotter pin? And how about this one here? Angle offset. And I can turn my cotter pin. Which is going to come in handy, you'll see. All right. Now I'm going to go open that cotter pin, change the color. Don't use red. Some of the highlighting colors are red. Excuse me, you should avoid it. But I know I'm still doing it. So I'm going to edit the definition of this sweep, the trajectory, and redo the trajectory. Go into my sketch view. So this says 0.75 here. So what I'm going to do is I'm going to actually add a tangent arc here at the end. Like so. And I'm just going to drag this back. Forgot what I had there, 0.75. Doesn't want me to change it. All right, well, I'm going to be lazy and leave it like it is. Actually, I probably should drag this one out a little bit. Like so. Okay. Okay. And there's my cotter pin. You can bend both sides. I'm going to be lazy here. Nope, should have bent them in the other direction, right? And turn off my datum plane, zoom in. I got an angle here. We could actually see what happens if I edit that. Let's activate it. No, I don't want to activate it. So I had to regenerate it before it give it to me back. Looks like I drug it in a bad position. There's my dimensions that are available. Let's go, how about 15? And regenerate. Well, almost okay. Change it a little bit more. All right. What I really wanted to do is get in there and get the angle dimension. There it is. Let's change that. Not bad, much better. There we go. Again, not supposed to use it on moving machinery, but we did it anyway. So now you can try, now we can try this, but for some reason I was working on it before and I couldn't get it to pattern. So we have the counter pin all the way up to the socket head cap screw. Capture those, right mouse button, group, right mouse button, pattern. Oh, it's okay. Reference pattern, check. And we got it going in all the directions. We got one sticking into the model here. So let's try this. Look for a command. I'm going to try component. Drag components, component operations. Let's try component operations. And we're going to transform. And we have to select the coordinate system, so of course we have to turn it on. And by the way, this is the coordinate system we want over here. This one, going down the middle of my component. Select the components to move, it says. So afterwards, let's select this first. Goes down the middle of the socket head cap screw. Now select the components to move. Now we should be able to just select the one component because it's the parent. Let's see if it works. Rotate. And we have to see what axis this is along. It's along the x-axis. And let's go 180 degrees. No, let's go 145. Done move. Done. And then of course we have to regenerate. And it moved it. Of course it did it even worse. It moved it into the thing. So you can see you have to work with that individually to get it to work. I should have only done about 90 so degrees, but did it too far. You can see the head sticking inside. But I'm not going to change it. You can do yours correctly. All right, now I'm going to put this in my standard orientation, which is kind of useless. I'm going to turn off all my datum features. Turn on my spin center so it spins it from the center of the model. I'm going to position it so it would look good maybe for a exploded view. And then I'm going to go into my view tab here And let's, instead of view, we can use the standard default, but you'll see that doesn't work that good. So into the view manager, if you recall, and get the view you want. That's the orientation. New, we'll just call it EX. And then let's go into explode. You can follow what's in lesson 12 in the book. I'll give these all the same name, EX. And under properties here, we're going to go and explode the position. And let's start off by clicking on this one, moving it out. How about move with children? All right. And again, you can move these to the positions they would work best in for your model. And you can reorient your model also. Not doing a very good job. What if we wanted to reorient the whole thing coming from the other side? Maybe look a little bit better, not much. So you're going to get the position you want for your exploded view, and then you're going to save it, of course, which I don't want to do. Make sure you follow the steps in lesson 12 to get this, I'm sorry, lesson 9. Lesson 12 will show you how to use it for a drawing. So you do want your exploded view and your orientation to be saved. This is the default on the other one. Also not very good. You've got your cotter pin sticking way out here. But you want to get a view that you like because you're going to use this on the drawing. And you can save the orientation. And of course you can orient it and then put it on the drawing later. It's good to have those views saved those for when you get to that time. The drawing, you want to tweak on the drawing view, but you don't want to explode it. It's too much effort in the drawing mode. Much better when you're in the assembly here. And at any time, of course, you can go in under your name views here and create a view. You can see here we've got one. There's one. There's two. So these were already created and saved to be used later when you're doing the drawing, and obviously when you're setting up your explode. All right, this completes the coupling assembly project.